Section 5. Build a text summarization system. In the first video, we will make an introduction to the problem and compare it with the machine translation system. Here, our goal is to make a system based on machine learning that, given a sentence, returns a shorter sentence that has a meaning that reflects as much as possible the meaning of the original sentence. So, how do we obtain this with TensorFlow? Again, sequence-to-sequence modeling. So, why this? Because the complexity is too high. But, similarly to the machine translation problem that we studied before, we don't have a fixed dimension for the output. If you, for example, look at different Wikipedia pages, the summaries of each page has a different length. This is quite trivial, but is the fundamental part of the problem. So, let's remind quickly the schema. So we have an encoder network that translates the input sentence into a smaller dimension representation of it. Again, remember the embedding layers. This representation, which is the output of the encoder, becomes the input of the decoder model that gives as output the summarized sentence. So we have full text, encoder, representation, decoder, and finally summary. So, the problems are exactly the same. Well, as we just pointed out, they are very similar. But compared with translation, in this case, you know that summary is supposed to be always a shorter sentence. Again, the text processing is the same as in the previous sections, except for the fact that we have to process separately main text and summary. The architecture, again, the main point on the architecture is that we need two models, one for the encoding task that generates the inputs for the second, that performs the decoding task. We have to mention that the notebook that we will use is inspired by the work by Amel Smu that you can find also in this GitHub repository. Concerning the dataset, we have this public domain dataset in which you can find Amazon food reviews. And in the next video, we explore this dataset and start building our model.